Welcome to Natural Selection, Bacterial Edition. It's me, Moser. After this video, you should be able to describe the conditions under which a natural selection occurs and explain how the conditions that are faced by bacteria could cause natural selection to occur. You've heard the word natural selection, so you've probably heard it tied to words like evolution, and perhaps you've heard it tied to the words survival of the fittest. But what does that actually mean? Does it mean that she's the one who's going to survive? No. We're not talking about physical fitness here. We're not talking about how many push-ups you can do or how fast you can run a mile. Well, we might be. We're talking about the one that's the best fit for their environment, who fits into their environment in a way that allows them to survive and succeed. Oh. You might have heard of this guy, Charles Darwin. He was a lot younger once. In 1859, he wrote a pretty important book. It's called Origin of Species. And it was his attempt to explain observations he had made while traveling around the world on a ship as a naturalist. What Darwin said was that species came from changes that happened in populations of any kind of organism, and that the way it happened, the mechanism by which it happened, was something called natural selection. So he boiled natural selection down to 4 things that he felt drove the process. Number 1, the idea that all populations have some variety among their members. There's natural variation. That the environment presents challenges to the survival of organisms in any population and challenges to reproduction. And that individuals, tend to make more babies than are going to survive. That there are more offspring produced than will actually survive. The 4th point that tied the first 3 together was that individuals with mutations or features that have some advantage for survival tend to pass on more of their genes. This is starting to sound startlingly familiar. So let's examine these 4 points of natural selection. Well, all populations have variation. In other words, we're all a little different. All populations, whether we're talking about humans or dogs, which are all one species, believe it or not, or something like ladybugs. Every species within any population is going to have some small differences, and those differences might be visible. In the case of these humans here, these lovely humans, we see differences in skin color and hair color. If we looked more closely, I'm sure we'd see differences in eye color or height. In the case of the dogs, yes, they really are all one species. We see differences in shape and fur length and height, in the shape of their ears, their face, in the shape of their tails. Lots of differences. It's a lot of variation. Even these ladybugs, and we tend to think that all bugs look alike, but these are all one species of ladybug, and look at how much variation there is in the shade, in the coloring on their elytra, their outer wings, in the number of dots, all kinds of variation. Yeah, we're all a little different. But how does that apply to bacteria? Well, you might remember we talked about the fact that in any population of bacteria, there will probably be some that have a thicker or thinner cell wall. There might be some that have a slightly different chemical composition on the capsule that protects them from the environment. Maybe some have 2 flagella. Maybe some have no flagella. Those are just natural variation. There's small differences between the members of a population. Okay, fair enough. The environment presents challenges? That's right. Life is tough. The environment presents challenges, and it's not always easy to keep from getting killed or to prevent your offspring from getting killed. Whether those challenges are things like a baking, broiling sun, heat, or a freezing tundra, cold. Whether that challenge is drought or that challenge is a vicious predator. Life is tough. It's not easy to stay alive. It's not even easy to keep your babies alive. How does this play out for bacteria? Well, they got all kinds of challenges. Life's tough. People boil stuff to sterilize it. How cruel. Life's tough. People wipe down stuff with disinfecting wipes. Kills 99.999% of bacteria. Yikes. Life's tough. There are challenges. People squirt alcohol all over everything. That kills bacteria. Life's tough. Just when a bacteria thinks they found a great place to live, a great host to mooch off of, to have their babies inside of, people go taking things like antibiotics, putting chemicals in that environment that are meant to kill. To kill! Life is tough. Many will die. Many are born, it's true. Many are born. Aww, many are born. But not all of them are going to live to grow up. Now, for humans, we do pretty well these days in the industrialized world. But for many species, it's still true that, oh, look at those adorable, sweet, furry little baby mink. Oh, look at those squished, flat adult mink. There are always going to be more offspring born in most populations than will live to grow up. Babies floating on the breeze. Oh, babies not taking root in dry soil or being killed by weed killer once they get established. You can have a whole bunch of babies. They're not all going to make it. More are born. Many will die. Well, how does that play out for bacteria? Bacteria just keep having babies. As long as conditions are right, bacteria keep producing offspring pretty much continuously. Now, mind you, they have to be at the right temperature. Not too hot, that'll kill them. Not too cold, that might kill them. This middle zone right here, well, we'll talk more about that when we talk about tolerance factors or tolerance ranges, but this is where bacteria are doing well. They're able to live and grow, and they're most certainly able to reproduce and grow their populations. Man, they can have a lot of babies. But remember, conditions aside, many will die. Many are born, but many, many will die. The best ones win. The living things that had whatever it took to survive, who had their babies and made sure their babies survived, get to pass on those wonderful genes of theirs. These are the winners. That mama right there, she is winning. What about this mama? Super mama. She's winning. She had what it took. She survived. And now she's making sure that her babies survive. What about bacteria? Oh, this doesn't sound good. Oh yeah, the best ones win, all right. The living things, the bacteria, that had whatever it took to survive and had their babies and make sure their babies survive, get to pass on those genes. This is not looking good. The bacteria that are resistant, the ones that have what it takes, that have that special something, a little mutation that they've picked up along the way, a piece of a plasmid, they're not going to be killed by any antibiotic. They're going to pass on their genes. Ooh. But I guess you shouldn't freak out. I mean, it's simple, it's natural, and it's inevitable. Okay, can you describe the conditions that are required for natural selection to happen? And can you explain how those conditions can actually be faced by bacteria and cause them to evolve antibiotic resistance? Good.